Williams. I am recording this video for Project 1 for EAS 4300 Propulsion Summer Class. We're going to start with the geometry. I'm going to drag over Fluent. I'm going to right click and open the design modular. Now that that's open, we're going to go over here to XY plane, center on the Z axis so we can see X and Y. We are going to go to sketching, polyline, this is just going to be rough until we put in the dimensions. Right click, closed end. For dimensions, I first started off by making sure all the parts were symmetric. So we want it symmetric across the x-axis, all of these points. And then for dimensions, I just used length. The outlet length is 0.97 meters. It's gonna look a little wonky until we put everything else in. And then for my inlet length, I did 0.7275 meters. And then for the throat length, I did 0.2425 meters. And then for the wall of the diverging part of the nozzle, I did, it's gonna be 1.4054 meters if you calculate everything. And then for the center line of the converging part, I just did 0.7. You can pick any. It's gonna be the same thing. We'll do length, so we'll go from this point to this wall, and we'll do, I did 0.7, but like I said, you can do whatever. So this is going to be the rough outline of your CD nozzle. For the next part, you're just gonna go to concept, surface from sketches. You're gonna apply it to this sketch, and then you'll just hit generate. Okay, next we're going to split the faces. Sorry, that was for my original mesh. We're going to make tighter faces around the throat so that we can control the meshing more. We're just going to select this face, right click, select look at, and then we'll go to sketching. We'll turn your thing this way. We're next going to separate the CD nozzle into two faces at first. Take it from this point to this point. Tools, face split. The target face is the CD nozzle, and then the geometry is going to be these 2 points, and then you'll just generate. So now we have now we have two separate faces. We're going to create two more faces around the center of the throat, like I said, to control the meshing. So it's pretty much going to be the same process. We're just going to create two lines again. It doesn't matter. Let's see. It doesn't matter what distance you do. For now, we're going to change that. We're going to draw another line here. Did it freeze on me? No. What's going on here? And we're going to draw the line here. Okay, sorry about that. We have to make sure we do that on the same plane, I just realized. So, same thing we were doing earlier. Drawing the lines. And then you can pick the distance from the throat. That's not perfectly... Oh my gosh. Okay, so I picked 0.15 meters from the throat center. Whoops, didn't mean to do that. Okay. Why is it saying that? I'm not sure why I can't make... Yeah, it should work now. Just made a new line. There we go. So yeah, so I did it 0.15 meters away from the throat. This one's already set. So now we're gonna do the same exact thing. We're gonna go to Tools, Face Split, select the target face, apply, and then the geometry here is going to be these 2 points. Did that work? Let's see. No, it didn't. Hold on. Okay. And then we'll generate that. And then we'll do the same over here. So we're gonna go Tools, Face Split, apply to this face. And then we'll generate that. And now we have 4 separated faces, so we are ready to go on to the meshing. Okay, it is loading. We are going to center it again, and then we're gonna come here. We're gonna insert method, and from method, first of all, we're going to apply it to this geometry. For method, we are going to do all quad. I guess I'll go ahead and generate that. Or, well, no, we'll wait. Next step is to do edge sizing. So we're going to go up here, and then you're gonna CTR or control click these 4 or 5 edges, and then we are going to right click one of them, and you'll just insert sizing here. We'll do change the type to number of divisions. We're gonna do 30 divisions. And then we are going to do the same thing for the wall. So the wall edges, I'm going to select all of them, should be 8. And you're gonna right click one, insert sizing. It's gonna be number of divisions again. And this time we're gonna do 20. That is it for edge sizing. And then we're just gonna generate that mesh. So we'll go here and we'll just do generate mesh. So now we have our mesh, but we're gonna make it more structured. And to do that, we are going to go to the face, gonna right click, insert, and it's gonna be face meshing. And then we're just going to generate this mesh again, and it should be more structured. Perfect. So the meshing is now done. We're gonna go into the setup. Okay, I actually forgot we have to make name selections. So this edge right here is going to be our inlet. This is going to be our outlet. And then you're going to CTRL click again. And these are going to be our walls. So now you have name selections for all three. Now we are ready to move on to the setup. So here we're gonna update the mesh. So it's updated now. We're just gonna go into the setup. I always do double precision, and then this student version only lets you do 4 solver processes. So I'm just going to do 4. Wait for it to start up. Okay, so my thing just crashed. I'm just going to move the geometry and mesh over, and then we'll go into the setup. Okay, so off of the top of my head, we are going to change. So we're going to come here, turn the energy equation on. We're going to change the method to inviscid. And then we're going to go over to materials, fluid, air. And we're going to change the density to ideal gas. That should be good. Oh, it's going to be density based. Sorry. So the type is density based. That's why this didn't look right. Change this back to ideal gas. Okay, actually it's not. Okay, everything else is the same. We're going to come to boundary conditions now. This is going to be a pressure inlet. And then our gauge total pressure at the inlet is 10 megapascals. And then we're going to change this also to 10 megapascals. The temperature is going to be 3000 Kelvin. Apply. We're going to go to outlet now. The pressure outlet is going to be just atmospheric, so 101.325. And then our wall should be good. I didn't change reference values. They're already 10 to the -3. or 1 to the negative 3. And then we're going to come to initialization, standard initialization, compute from inlet. These both look right, so we'll initialize. Run calculation, we're gonna do 500 iterations. And yeah, we'll just calculate now. So now the calculations are done. We're going to check our contours. I always start off with the Mach value contours, or Mach number contours. So perfect. So our contours are perfect. Starts off low here, should start at 0, go to 1, and then they increase. So these contours are good. The other contours we need are velocity, compute. Contours are perfect. Pressure. These are perfect. Now temperature. Perfect. The last one is going to be speed of sound. These are perfect. So you can also get these contours and plots in CFD Post, but it's really quick to just do it here as well. It's the same contours. So I did it for my project in CFD Post, but I realized that you can do it here too. So for the video, I'm just going to keep it at this. For the plots, there's going to be a little more to it. So you're going to go to XY plot. What you're going to have to do is create a new surface, line rake, and you're going to name it sensor line. You're going to set x0 to negative whatever value you had for your converging center line. And then x1 is going to be whatever value you had for your diverging center line. So I had 1.357533481. This is pretty much just going to be the length of the center line. So we're going to create that. And then this is the center line you're going to use for all your plots. So I guess we'll just start with pressure. Just save /plot. This is going to be your pressure center line plot. Next is density. There we go. Next is velocity. And then Mach number. And then temperature. And then speed of sound. So they're all perfect. I did forget to show, whoops. I did forget to show one more contour is a density contour. So this is perfect too. The last thing we're gonna do is see how to calculate the inlet outlet values for temperature, density, etc. You're basically just going to go to reports. You're going to go to surface integrals, area type, change it to area weighted average. You're going to come, so for all the inlet values, you're going to select inlet. You'll compute, it'll show it down here, it'll show it right here. You'll do the same for each one. Density, velocity, Mach number, temperature, properties, speed of sound, and then you'll do the same thing for the outlet. You'll just select outlet, make sure to deselect inlet, and then you'll do it all over again. Whoops, that was the wrong thing. Density, velocity, Mach number, temperature, and then speed of sound. So those are all how to get the plots, the contours. the XY plot, or sorry, I said that. The XY plots, contours, the inlet outlet values, and then that's the geometry, meshing, the setup, and that is everything.